Integration by parts on definite integral, not a difficult problem, just do an extra fundamental theorem of calculus. So the first one is integral from 0 to 1. We have an arctangent x dx. Arctangent is the same thing as inverse tangent. So the first step is you are going to let u equals to arctangent x, the derivative of that, du arctangent, that is 1 over 1 plus x squared dx. And then the dv, you pick the entire arctangent already, so you only have a 1 times dx, and then the integral of that, v, is the integral of 1 dx, that is equals to x, right? And then for the integration by parts, you have uv minus the integral of v du. So uv, that is x times arctangent x, so you have an x times arctangent x, and then minus the integral of v du, which you have the x multiply the fraction, right? X divided by 1 plus x squared dx. And then this one, for the integration by parts, so the first thing that you will have to do is you will have to add that this one is x goes from 0 to 1, and then this is also from 0 to 1. So for the uv from 0 to 1, you have a 1 times arctangent of 1, but when you plug in a 0, 0 times arctangent of 0, the whole thing is equals to 0. And then arctangent 1, that means a tangent of what is equals to 1. So tangent is y over x. The possible number, the possible answer is you have a pi over 4, and then a minus a 0. And then on the other hand, for the x over 1 plus x squared, this is a u substitution. Then you will have to, let's do the u substitution in a different color. So this is a u substitution, right? So this is a u substitution. I am going to let u equals to 1 plus x squared. Du is equals to 2x dx, and then 1 divided by 2x du equals to dx. Since the 0 and 1, they are in x, you have to put them in u, so you have to tell me what u of 1 equals to. That is 1 plus 1 squared equals to 2, and then u of 0, that is 1 plus 0 squared equals to 1. And then you will have an integral u equals to 1 to u equals to 2. You have your x divided by u, and then 1 divided by 2x du, right? This is from the change of variable. You are going to replace this dx to this dx. So that's how I got a 1 over 2x du. And then the x got cancelled. You have a 1 over u, right? So this is a 1/2. And then you have an ln, absolute value of u, ln absolute value of u. U goes from 1 to 2, and then you have ln 1/2 ln 2 minus 1/2 ln 1. So 1/2 ln 1, and then ln 1 is equals to 0. So this is just equals to 1/2 ln 2, right, from the u substitution. And then as a result, what is the final answer equals to? The final answer is equals to pi over 4, and then you are subtracting this, right? You are subtracting the 1/2. So you are subtracting the 1/2 ln 2, and then this is your final answer to the first integral. Okay, so nothing is crazy, just you have a u substitution hiding inside an integration by part. To be honest, that is a very good practice. And then moving on to the next problem, we have a x times sine of x. Let's do that. So we have x times sine of x. So this time I am going to let u equals to x, and then du is equals to 1 times dx. And then on the other hand, you have your dv equals to sine of x dx, and then v is the integral of that, sine of x, and then dx, that is equals to negative cosine, so negative cosine of x. And then I want to show more on one page, so I'm going to move this up a little bit. And then you will perform your integration by parts, uv minus the integral of v du. The uv gives you negative x times cosine of x, such that x goes from 0 to pi over 2 minus the integral of v du. So that is a negative cosine of x du is equals to dx. So this is x goes from 0 to pi over 2. So plug in the pi over 2. What do you have? You have negative pi over 2 and then cosine of pi over 2. And then when you plug in a 0, you are subtracting just as subtract a minus 0, which is subtracting a 0. By the way, cosine of pi over 2 is equal to 0. Pi over 2 is 90 degrees on the y-axis. At that point, x is equal to 0. So this is equal to 0 as well. So the whole thing is just a 0. And then you have a plus minus minus, you have a plus, right? Minus minus, the two minuses, that gives you a plus. The integral of cosine gives you a sine of x. X goes from 0 to pi over 2. And then we will have a sine of pi over 2 minus sine of 0. Sine of 0 is equal to 0. Sine of pi over 2, unit circle, 90 degrees, y is equal to 1. So we did all the work for this one. All right, so moving on to the last problem, the red problem, we have a definite integral from 0 to 1. We have an arc sine. Arc sine is inverse sine of x. So let's do that. So for that problem, I am going to let u equals to, let's just put this right here because I'm using the color code, right? So arc sine, Mr. C. So arc sine of x, and then du is equals to, the derivative of inverse sine is 1 over the square root of 1 minus x squared dx. This is the derivative of inverse trigonometric function. If you don't remember any of this, I do have several video about this on my channel, so go check it out. I think I just labeled the videos like the derivative of inverse trigonometric function. And then the other one, we have a dv equals to 1 times dx because we took everything already. So integral of that is just equals to x. And then you have your uv minus the integral of v du. So you have your uv minus the integral of v du. And then uv is x times arc sine, Mr. C, arc sine of x, and then x goes from where to where? X goes from 0 to 1, and then minus the integral of v du. So you will have your x over the square root of 1 minus x squared dx. And then what do you get for the arc sine? So for the arc sine, you have 1 times arc sine of 1, and then once you plug in the 0, everything becomes a 0. So what is arc sine of 1? That means sine of what is equals to 1? The answer is, the first number that comes into my mind is pi over 2. So this is actually just a pi over 2. The 0 is 0, right? And then how about the definite integral? So that definite integral is a u substitution. So I'm going to do this, and then this is a u substitution. So this one, we already wrote the uv minus v du, so it is okay to define another u. And then this u has nothing to do with the u right over here. It's just a brand new u. I just use that for the u substitution. U equals to 1 minus x squared, du equals to negative 2x dx, 1 divided by negative 2x du equals to dx. And then don't forget that this is from 0 to 1. They are x. So I supposed to write x equals to 1 and x equals to 0. And then you will have to find out u of 1. What is that equal to? 1 minus 1 squared equals to 0. And then u of 0 is 1 minus 0 squared equals to 1. And then you will have integral u equals to 1, u equals to 0. And then you have your x divided by the square root of u, which is u equals to u to the 1/2, and then multiply dx is 1 over negative 2x du. Now the question that you want to ask me is, hey, for the definite integral, the upper limit is greater than the lower limit, but this time the upper limit is 0, the lower limit is 1. Does that cause a problem? The answer is no. when you do the change of variable, change from what x equals to what u equals to, it is normal to get this. This is completely fine. When you change from x to u, it's completely fine. Don't worry about it. Then what is this? X is gone. Then you will have to integrate. So you are trying to integrate u to the negative 1/2, right? So you have pull the negative 1/2 out, and then you have integral from 1 to 0, u to the negative 1/2 du. This is easy. You have your negative 1/2, and then this is u plus 1. You have a 1/2 reciprocal. You have a 2, and then this is u goes to 1 to 0, and then you have your negative, right? Just a negative, and then you have a square root of 0 minus square root of 1. Then what is that equal to? That is equals to minus, this is a negative 1, so you will have a plus 1. So at the end of the day, and then you will just have now pay attention, this is equals to 1, right? 1 from the u substitution. Okay, it's a positive 1, right? Is this correct? Tell me, is this correct? Pi over 2 plus 1. Is the plus 1 correct? If you say yes, then you might lose some points, because what you overlook is right over here. So this is, you are subtracting the result of this definite integral. So this is going to be a pi over 2 minus a positive 1. So instead of a positive 1, you will have to change that to a big minus. So pi over 2 minus 1 is the correct answer due to the minus. Where is the minus came from? The minus came from the integration by parts right over here, and then you distribute the minus in, then that's how you get the minus 1, minus a negative, minus a positive 1. All right, so that is the end of this video. If you like the way I explain calculus, give me a thumbs up, subscribe, highly appreciate that, truly appreciate that. I will see you all in the next video. Signing out.